Welcome to the Deep Dive. We're here to give you those key bits of knowledge without you needing to wade through hours of material. Today we're jumping into Unreal Engine 5.
Mm.
Think of it as a shortcut, really, to understanding this super powerful tool. And it's not just games we're talking about. This engine is popping up everywhere. Architecture, film, you name it.
That's absolutely right. And our source material for this, interestingly enough, is actually a massive free online course. So we've basically taken that, boiled it down, pulled out the really crucial stuff for you. We want to highlight what Unreal Engine 5 can do, its core mechanics, so you walk away really understanding its potential, whether that's for games or, like you said, ArchViz, filmmaking, whatever.
Okay, so let's kick things off with maybe the first question people have.
Yeah.
Accessibility. Getting started. Unreal Engine 5. It's completely free to download, right? Free to use for your own projects, internal stuff, even making games.
Exactly. Totally free to get going. Now, people hear royalties and sometimes get a bit worried, thinking it's expensive. But the deal with Epic Games is they only ask for a 5% royalty after your title, whatever it is, makes over $1 million in revenue.
$1 million. Okay, so that's quite a high threshold.
It really is. It basically makes it fantastic for beginners, for hobbyists, even for medium-sized indie studios. You can build, you can experiment, launch something commercially, all without those upfront costs. You only share the success if you, have a significant success.
Yeah, that sounds like a massive help for independent creators. Definitely. Okay, so you download it. What hits you first? Is it just like a blank screen, an empty editor?
Oh, not at all. You get the Epic Games launcher first, and honestly, it's way more than just a button to start the engine. Think of it as a resource hub. It's packed with fully functional sample projects, things like the Lyra FPS, that's a pretty well-known first-person shooter sample, or Crop Out, which is an RTS game,
Okay.
but also things like a car configurator, a broadcast sample. These show you straight away that Unreal isn't just for games. You see its power for, interactive films, detailed architectural visualizations, virtual production.
And those samples aren't just empty shells, are they? They're like complete projects you can actually dig into.
Exactly. You can pull them apart, see how they work, learn from them, even grab bits to use in your own stuff.
Nice. And speaking of cool features right there in the launcher, metahumans.
Ah, yes. Metahumans. They are pretty incredible. It's a system for creating hyper-realistic digital characters.
Mhm.
We're talking super detailed faces, expressions, perfect for cinematics or any project where you need that high level of realism.
And assets. I heard something about free stuff.
Definitely. Don't skip the Marketplace tab. Around the 5th of every month, Epic releases a free for the month collection. You can claim these assets. Maybe it's a character pack, environment assets. Like 1 month they had a renovation simulator pack. You just click claim and they're yours to keep forever. Use them in any of your projects.
Wow. Okay. So it's like building up a free asset library just by checking in.
Pretty much, yeah. High quality stuff too.
So for someone just starting, maybe feeling a bit overwhelmed, which engine version is the one to grab? Does it matter much?
Well, the source material we looked at suggests starting with either Unreal Engine 5.2 or 5.3. Honestly, there isn't a huge difference in the layout or the core feel between them for a beginner, so either one is a really solid place to start.
Okay, 5.2 or 5.3. Got it. So you're in the engine,
Right.
and you immediately start hearing about these two big things, Lumen and Nanite. They sound impressive, very technical. But like, for someone actually trying to build something, what's the real impact? How do they change how you create?
That's a great question. Let's break it down. Lumen. Think about lighting. Traditionally, a lot of lighting in games had to be baked, pre-calculated, static. Lumen is dynamic global illumination and reflections. It means artists can change the time of day, blow up a wall, move lights around, and the lighting just updates. Realistically,
Isn't it
instantly.
Without needing to recalculate everything.
Exactly. No long waits. It's massive for artistic freedom. You just create.
Okay, that sounds huge. And Nanite.
Nanite is all about geometry, the actual 3D models. Imagine you have an incredibly detailed movie model, like millions and millions of polygons.
Yeah, usually that would kill performance in a game.
Right. But Nanite is a virtualized geometry system. It cleverly only draws the detail you can actually see right when you need to see it. So you can use these ultra-high detail assets directly in your game or scene without worrying about performance tanking. Artists can just import incredibly detailed models, and Nanite handles the optimization.
So less time optimizing, more time creating amazing visuals.
Precisely. More detail, smoother performance. It lets artists focus on the art.
That really is a leap. Okay, so with all this power,
Yeah.
how do you always start putting something together? What's step one?
The easiest way in is definitely using the templates, especially if you're making a game. Grab something like the third-person template. It gives you a ready-to-go character camera setup, basic movement. It lets you start experimenting with the engine's features right away, rather than, getting stuck building basic movement systems from scratch.
Makes sense. Focus on the fun stuff first.
Yeah.
Now, logic. You need to make things happen. Big choice. Blueprint or C++ phase. What's the deal there, especially for beginners?
Okay, so Blueprint is Unreal's visual scripting system. Imagine connecting nodes like digital Lego blocks. Each node represents a bit of C++ code underneath. It's incredibly powerful and makes programming accessible even if you're not a traditional coder. You'd be surprised how many big games, like Valorant, for example, use blueprints heavily.
Really? So you don't have to be a C++ wizard?
Not at all, especially not starting out. C++ is there, yes.
Yeah.
It offers the absolute peak performance and the most flexibility for really huge, complex systems. But for, I'd say, the vast majority of projects, even ambitious ones, you can achieve so much just using blueprints. It's definitely the place to start.
That's probably relief for a lot of people listening. Okay, before you even drop your first cube in the world, there are project settings. What kind of key stuff do you set up there?
Yeah, project settings are like the blueprint for your whole project. You'll define your target platform, desktop, mobile, console, whatever. You set the quality preset. Are you aiming for maximum visual fidelity or something more scalable that runs well on lower-end hardware?
Performance versus looks, basically.
Kind of, yeah. And you can enable or disable big rendering features here too, like ray tracing. Ray tracing gives you super realistic lighting and reflections, but it does cost more performance. So it's where you tell the engine the basic rules and targets for what you're building.
And just to drive home how capable this engine is, what are some big-name games people might know that are actually built using UE5?
Oh, the list is growing fast. You've got Arc 2, that huge survival MMO, Black Myth Wukong, which just looks graphically insane.
Yeah, I've seen trailers for that. What's incredible.
Right. Then there's Smite 2, the MOBA sequel, Stalker 2, that intense shooter. And of course, you can't forget Fortnite. Epic Games makes Unreal Engine, and Fortnite is basically their massive, constantly evolving showcase for it.
So everything from stylized shooters to hyper-realistic RPGs.
Exactly. Huge open worlds, cinematic experiences. It really shows the range.
All right, foundation's laid. I'm itching to actually get inside the editor now. You open it up.
Yeah.
What's it like? Where do you start in that digital workspace?
Okay, stepping into the editor. First thing, efficiency is key. You got to learn the hotkeys. Q is for select mode, W for move, E for rotate, R for scale. Just drilling those into muscle memory saves so much time clicking around.
E for rotate, right? I always mix that one up. Okay, Q, W, E, R. Got it. What about placing things precisely? Snapping.
Absolutely essential. Snapping lets you move or rotate objects by fixed increments, like move exactly 10 units or rotate exactly 15 degrees. Super helpful for lining things up perfectly, especially with modular pieces, but you can easily toggle it off for freeform, smooth movement when you need that fine touch.
And if you're working on a massive level,
Yeah.
moving around.
Camera speed. There's a little slider for it. Crank it up to fly across big environments quickly. Dial it down for close-up work. Simple, but crucial.
Any other quick workflow tips? Duplicating things.
Oh yeah, golden shortcuts. Hold Alt and left click drag an object, boom, instant duplicate.
Nice.
Want to duplicate and have the copy follow your mouse. Alt plus shift plus click drag.
Ooh, handy.
And the end key. Select an object, hit end, and it snaps straight down to the floor beneath it. No more fiddling trying to get things grounded.
Okay, the end key. I'm writing that one down. That sounds like a lifesaver.
It really is. Little things like that add up massively over time.
So you're moving stuff around.
Yeah.
Now you want it to do something. Let's talk blueprints, again, visual scripting.
Yeah.
What's the hello world of Unreal Engine?
The absolute basic is the print string node. You usually put it in the level blueprint to start, connect it up, type some text in it like hello world, and when you run the game, that text pops up on screen or in the output log. It's just your basic way to confirm, yep, this bit of script is running.
Simple feedback. And what makes it run? The trigger.
The most common starting trigger is the event begin play node. Anything connected to this will execute the moment the level starts or the moment a specific blueprint actor is spawned into the world. It's your starting gun.
Gotcha. Okay, beyond scripting, just navigating the editor window itself, what are the key panels we need to know about?
Right, the main ones. First, view modes. You can switch how you see the scene. Lit shows everything with lighting, shadows, the works, but unlit mode strips all lighting away. Sounds weird, but it's incredibly useful for editing in really dark areas where you literally can't see the objects otherwise.
Ah, Okay, so you can still select and move things even if they're in shadow.
Exactly.
Hmm.
Then there's the details panel. Select anything in your level, a light, a mesh, a camera, and this panel shows all its properties. Location, rotation, scale, material, specific settings,
That's where you tweak everything.
pretty much. And a cool little trick. In the number fields, like for location X, you can actually type math. Like type 2 after the number, hit enter, and it'll multiply the value.
Oh, neat. Like a little built-in calculator.
Kinda, yeah. Saves grabbing a calculator. Yeah. And for making things react realistically, you'll often use simulate physics and enable gravity checkboxes in the details panel for specific objects.
Right. Make boxes fall, that kind of thing. And where do all your assets live? Models, textures, blueprints?
That's the content drawer or content browser. It's your file explorer for the project. All your meshes, materials, sounds, blueprints, everything you import or create lives in here. Keep it organized.
Good advice. Now, let's dive a bit deeper into blueprints. There are these core classes, right? The sort of fundamental types of blueprints. Can you walk us through the main ones?
Sure. Think of it like a hierarchy. At the base, you have the actor. An actor is basically anything you can place in your level. A chair, a light, a trigger volume, a particle effect. It's the most fundamental thing.
Okay, anything in the world is an actor.
Pretty much. Then you have a pawn. A pawn is a special kind of actor that can be possessed by a controller, either the player or AI. It can receive input. Think of a vehicle you can drive, or maybe a turret.
So something controllable.
Right. And then a more specialized pawn is the character. A character is designed specifically for, well, characters. It comes with built-in movement capabilities, walking, running, jumping, swimming, flying even. Your player avatar in most games is usually a character.
Like in Fortnite.
From-
The person you run around as.
Exactly. Now, who controls the pawn or character? That's the player controller. It represents you, the player, in the game. It takes your keyboard, mouse, or gamepad input and translates it into actions for the pawn character it's possessing.
Okay, so player controller is the brain, character is the body.
Kinda, yeah. Then, setting the rules for the level, you have the game mode base. This blueprint defines things like, what kind of character does the player spawn as? Are there points? How do you win or lose this specific level? You can have different game modes for different levels.
So rules for the current match or level.
Correct. Tracking the overall state across the game, maybe across multiple levels or rounds, is the game state base. Think of stuff like the total match time remaining in a multiplayer shooter, or maybe the overall score that persists.
Global game info.
Yep. And finally, storing info specific to each player, especially in multiplayer, is the player state. This holds things like the player's name, their individual score, maybe their team, or current health if you want it separate from the character. It's useful in single player too sometimes.
Okay, that clarifies how those different pieces work together.
Yeah.
Actor, pawn, character, player controller, game mode, game state, player state. Got it. Now, inside these blueprints, you store data using variables. What are the sigil types we need to know?
Right, variables. You'll use these constantly. The simplest is a Boolean. It's just true or false, perfect for flags like is dead, is door open, on or off.
Simple switch.
Exactly. Then integer for whole numbers. Score, ammo count, number of lives. 1, 2, 3, no decimals.
Okay.
If you do need decimals, for precision, that's a float. Think health points like 99.2 or precise physics calculations, speed, things like that. Floats are super common.
Health bars, yeah. Decimals needed there.
Definitely. For text, you have a few options. String is your basic text holder, good for internal names or simple messages. But if you ever plan to translate your game into other languages, you must use text. It's specifically designed for localization.
Ah, okay. Text for anything the player sees that might need translation. Good tip.
Very important, yeah. Then you get into 3D space. A vector stores 3 numbers, x, y, and z, used for position in the world, movement direction, velocity. Anything with 3D coordinates.
Location and direction.
Rotator also stores x, y, z, but these represent rotation angles. Pitch, yaw, and roll, used for, well, rotating things.
Makes sense.
And finally, transform. This is a really useful one because it bundles location, a vector, rotation, a rotator, and scale, another vector for size, all into one single variable. Super handy for placing and orienting objects.
Okay, Boolean, integer, float, string text, vector, rotator, transform. Covers most bases. Now, reusable code blocks. Functions versus custom events. When do you use which? What's the practical difference?
This is a common point of confusion, but it's actually pretty straightforward. Both are blocks of blueprint nodes you can call from elsewhere. The main difference, functions cannot have delay nodes inside them. They run instantly from start to finish. They also can have outputs, meaning they can return a value back to whatever called them.
Okay, instant execution can give a result back.
Right. Custom events, on the other hand, can have delay nodes. So you can make them wait, do something, wait again. Perfect for sequences over time. They typically don't return values directly.
So use custom events if you need pauses or timed actions, functions for quick calculations or actions that need to give back a result immediately.
That's a great way to think about it, yeah. Choose the tool that fits the timing and output needs.
All right, theory is great, but let's see this stuff in action. We looked at some minigame projects. Let's start with a 3D platformer. Instead of every little step, what are maybe the top 2 or 3 big concepts someone really learns building that?
Okay, the 3D platformer project is fantastic for learning, I'd say. 1. Timelines. These are incredibly powerful for creating smooth, animated movement directly in Blueprint. You set keyframes, define curves. Perfect for making a platform move back and forth predictably, or maybe a door smoothly swinging open. Really precise animation control without needing an external animation program for simple stuff.
Like animating objects in the level itself.
Yes, exactly. 2. Blueprint interfaces. This is a really important concept for clean code. Instead of one blueprint needing to know exactly what type of other blueprint it's talking to, which is called casting and can get messy and slow, interfaces act like a contract. You define functions in the interface, like kill player or add coin. Any blueprint can then implement this interface, promising it knows how to handle those functions. Then other blueprints can just send a message via the interface, and whoever implements it will respond.
So it's like a standardized way for blueprints to communicate without being tightly linked.
Precisely. Much cleaner, better performance, more flexible, a really core concept for bigger projects. And maybe a third one. Instance editable variables. This is huge for level design. You make a variable in your blueprint, say a speed variable for a moving platform, and you tick instance editable. Now, when you place multiple instances of that platform in your level, you can select each one individually and type in a different speed value right there in the editor's details panel without changing the original blueprint.
So you can easily make variations of the same object, like one platform moves fast, another slow.
Exactly that. Creates variety super easily.
Okay, timelines, interfaces, instance editable variables, great takeaways.
Yeah.
And I guess you also naturally cover things like collision for hitting obstacles or picking up coins, and basic UI like a death screen or showing the coin count.
Oh, absolutely. Collision components are fundamental, using boxes or spheres to detect overlaps. And yeah, basic UI is crucial, showing the player's score, popping up a "you died" message, adding a button to respawn, managing whether the mouse cursor should be visible for the UI or hidden for gameplay. All standard stuff you practice here.
Right. Okay, let's switch gears. Minigame 2. A 2D clicker game. This one starts from a blank project, no template. What key ideas really stand out when building this type of game from scratch?
Good question. The clicker game forces you to focus on a couple of different really important concepts. 1. The game instance. This is a special kind of blueprint that, unlike the game mode, which resets when you change levels, persists for the entire duration the game is running.
So it stays loaded across levels.
Exactly. It's the perfect place to store data that needs to survive level changes or even game sessions, potentially. Think your total number of cookies, your upgrade levels, stuff that defines your overall progress. You set it up once in the project settings.
Okay, persistent global data storage makes sense for a clicker.
2. UI-driven gameplay. In a clicker, the user interface is the core gameplay loop. So you dive deep into creating UI widgets, making buttons interactive, displaying information that updates constantly, and importantly, setting up your player controller to specifically handle UI interaction, making the mouse cursor visible, ensuring clicks hit the UI buttons, not something in a hidden game world.
Right, the focus shifts heavily to the UI layer.
Totally. And 3, timers for passive income. A core mechanic of clickers is earning currency over time. You learn to use the set timer by event node. This node lets you call a specific function or event repeatedly, say every 1 second. So you'd use it to trigger an event called add passive cookies every second, making the player's score go up automatically based on their upgrades.
Automating that core loop. Got it. And I imagine you also get into the logic for buying upgrades, like checking if the player has enough cookies using a branch node.
Oh yeah, absolutely. Conditional logic is key. You check, are current cookies greater than or equal to the upgrade price? If yes, subtract the cost, apply the upgrade, maybe increase the price for the next one. If no, false, maybe show a not enough cookies message.
Standard shop logic.
Standard shop logic, exactly. And constantly updating the UI text to show the current cookie count, the cookies per second rate, the cost of the next upgrade. It all ties together. Plus, building a simple main menu screen with a play button that loads the clicker level makes it feel like a complete little package.
Cool. Okay, third mini project. A collecting game. The goal is simple: collect X items to open a gate. You mentioned this is a great place to really hammer home event dispatchers. Why are they such a good fit here?
Because it elegantly solves the communication problem. You have collectibles, a UI displaying the count, and a gate that needs to open. How do they all coordinate? Without event dispatchers, you might be tempted to have the gate constantly check the player's coin count, or have the collectible try to find the UI and the gate directly. It gets messy fast.
Right, lots of dependencies, potential for things breaking if you change one part.
Exactly. But with event dispatchers, it's decoupled. Think of the dispatcher like a notification system or a radio broadcast. You create an event dispatcher, maybe called onCollectible inside the collectible blueprint.
Okay, the collectible has the broadcast.
Right. Then other blueprints that care about this event, like the player's UI blueprint to update the count, and the gate blueprint to check if it should open, can simply bind or subscribe to that dispatcher.
They tune into the signal.
Precisely. So when the player picks up a collectible, that collectible just fires off its on-collectible picked-up signal. It doesn't need to know who's listening. The UI hears it, updates its display. The gate hears it, checks if the required count is now 0, and if so, triggers its opening animation, maybe using a timeline again.
Ah, that's much cleaner. The collectible just shouts, "I was picked up," and whoever cares can react accordingly.
You got it. It keeps everything nicely separated and easy to manage.
And I suppose for the actual end of the game, like triggering a U1 screen, when the player reaches the finish line after opening the gate, you'd probably use an interface again, like we discussed for the platformer.
That would be the clean way, yes. Create a simple interface, maybe BPI game events with a function like game finished. Have your game mode implement this interface. Then when the player overlaps with a finish zone actor, that actor just calls the game finished message via the interface on the game mode. The game mode then handles displaying the U1 UI, stopping gameplay, etc. Again, avoids direct testing.
Interfaces for commands, dispatchers for notifications. Seems like a good pattern.
It's a very robust and common pattern in Unreal development. And yeah, managing input modes, hiding the cursor and setting input to game only during play, then showing cursor and setting UI only for menus is constantly reinforced across all these.
Okay, shifting from gameplay to UI tools.
Yeah.
Let's talk about this modular master button. You framed it as a real time saver. What problem does it actually solve?
It solves the massive headache of keeping UI consistent and saving time. Think about any game menu, main menu, options, pause, inventory. They all have buttons, right?
Yeah, usually lots of them.
And you generally want them to look similar, same font, same basic shape, maybe slightly different colors or text. Instead of creating and styling every single one individually, you create one master button blueprint.
A template button.
Exactly, a reusable template.
So how do you make one template button work for all the different text labels and maybe slight variations it needs?
That's where instance editable variables come in again, but this time inside a UI widget blueprint. The master button structure might be simple. Maybe a size box to control dimensions easily. Inside that, a standard button widget, and inside that, a text block. Then you create variables within your master button blueprint for things you want to customize. A variable of type text called maybe button label, a variable for font info, size, style, variables for width and height, variables for background color, text color.
Okay, variables for all the changeable bits.
Right, and you mark all these variables as instance editable and probably expose on spawn. Now, when you drag your master button widget onto another UI canvas, like your main menu widget, you'll see all those variables appear in the details panel for that specific instance of the button. You can just type in play game for the label, set the size, pick the colors, right there.
Ah, so you customize each copy without changing the original template.
Exactly. Massive time saver, ensures consistency.
But wait, how do you make each button do something different when clicked? If it's the same template, don't they all do the same thing?
Great question. That's where event dispatchers make another appearance, perfectly suited for UI events. Inside your master button blueprint, you find the actual base button widget and its built-in on-clicked event. From that event, you call a new event dispatcher that you create on the master button itself. Let's call it on master button clicked.
Okay, so the internal click triggers an external signal.
Yes. Now back in your main menu widget where you placed an instance of your master button and set its text to play game, you select that master button instance. In its details panel, you'll now see your on master button click dispatcher listed under events. You can click the little plus icon next to it, and it creates an event node right there in your main menu's graph. You connect nodes to that event to define what happens when that specific button is clicked, like opening a level or printing play to the screen.
Whoa, okay. So the master button provides the click signal, but the action is defined wherever you use the master button.
You've got it. Completely modular, reusable, and powerful. Saves enormous amounts of repetitive work. You can even use the pre-construct event in the master button to make it update its appearance in the editor as you change the instance variable so you see what it looks like live.
That is genuinely a game changer for UI work.
Mm-hmm.
Okay, so we've built our games, perfected our UI, final hurdle, getting it out there, packaging the game. What's involved?
Packaging is basically bundling everything up so someone else can run it without needing the Unreal editor. The first stop is project settings again. You need to fill out the project info section, give your game a proper name, a version number like 1.0, your company name, maybe a copyright notice.
The metadata.
Right. And the display title, that's what shows up in the title bar of the game window, important for branding.
And defining how the packaged game actually starts.
Crucial. Under Maps and Modes, you set the game default map. This is usually your main menu level. You also make sure your default game mode and, importantly, your game instance, if you're using one for persistent data, are correctly set here for the packaged build.
Okay, telling it where to begin.
You can also add intro movies here, maybe company logo, stuff like that. Under supported platforms, you should ideally tick only the platforms you're actually targeting, like Windows. It can help trim down the package size.
Makes sense. And the visuals? Splash screen icon?
Yep, you can customize the image that pops up briefly while the game loads, the splash screen, and the actual icon file that represents your game on the desktop or taskbar gives it that professional touch.
So settings all dialed in. How do you actually, press the build button?
It's pretty straightforward. You go to the Platforms menu at the top of the editor, choose your target platform, say Windows. Then you'll see options like development, shipping, etc. For a distributable version you want to give to players, you choose shipping. That builds an optimized version without the debug tools.
Okay, shipping build for release.
Then you just click Package Project. It'll ask you where you want to save the package game. Choose a folder. The very first time you package, it might take a little while, maybe 5, 10, 15 minutes, depending on your project size and computer speed, because it has to compile everything.
Education at the front.
Exactly. But subsequent packages are usually much, much faster because it only rebuilds what's changed. And when it's done, you'll have a folder containing your game's executable file, .exe on Windows, and all the necessary data files. You can zip that folder up and distribute it.
Wow. And just like that, you have a standalone game. What an incredible journey we've covered today. Seriously, from just the basic idea of what Unreal Engine 5 is, its accessibility, all the way through core features like Lumen and Nanite, diving into blueprints, building actual mini-games, learning about timelines, interfaces, game instances, event dispatchers, that modular button trick, and finally packaging it. You listening have genuinely gained some solid practical knowledge here.
Absolutely. And it's worth reiterating, these concepts, these tools, blueprints, interfaces, managing game state, building UI, they aren't just for making games, even though that's often the focus. Think about creating an interactive walkthrough for an architectural design where a client can change materials or furniture in real time. That uses the same UI principles, maybe timelines for animations, or virtual production for film, visualizing complex scenes instantly. That leverages Lumen, Nanite, and the core engine capabilities. The underlying principles are broadly applicable to so many forms of real-time 3D creation. So really, the encouragement is to just jump in, experiment, build on these foundations. These powerful tools really are within reach.
Yeah, it feels like the barrier to entry for creating these really rich, immersive digital experiences is lower than it's ever been. So the final thought for you listening is, now that you've got these core concepts under your belt, what incredible worlds, what useful tools, what amazing experiences will you build?